Good morning, everyone. Thanks for coming. How's everyone doing?
Great.
All right. Welcome to our first episode of Tech Time with Tanmay. This is going to be a new series that Tanmay is going to host, and I'll introduce him in a minute. But we're here today from the IBM Canada Lab in Markham, Ontario. So welcome to all for coming. And what we're going to be doing today, Tanmay's got a couple of special guests, two IBM fellows, Rob High and Sam Lightstone, and they're going to be talking about demystifying AI. So in the last couple of years, we've heard a ton about AI, and it's been ramping up, and we're going to continue to hear more and more over time. This year is going to be a turning point, in my view, on operationalizing artificial intelligence. So we're very excited about that. So Tanmay is, I met him a couple years ago. He was 14 when I met him, and I keep getting blown away how smart this guy is. So I'm going to introduce him. Come on up, Tanmay. And he's now 16 years old, and he continues to impress all of us on how smart and dedicated, passion, and everything that he can do. So Tanmay,
thank you
welcome,
very much.
and thank you.
Thank you very much, Steve. All right, thank you very much. Hello, everyone, and welcome to the very first episode of Tech Time with Tanmay. This is really exciting. Really, the goal of this series is to sort of bridge the gap between the experts and the people that actually work in the field and have been doing so for years, and people that use that technology every single day, but don't really know what happens behind the scenes or behind the curtains from the technical angle. Now, for the past 5 years, I've been working with all sorts of next generation technologies. And of course, the one that I am most passionate about, the one that has piqued my interest most, is the technology of artificial intelligence. Now, personally, whenever I use artificial intelligence technology, whenever I implement it, or whenever I talk about it, I don't like calling it artificial intelligence. I feel like AI doesn't live up to its true meaning. Rather, I always prefer to use the term machine learning technology, as I personally believe it's more accurate. But just for now, let's ignore that custom nomenclature and let's go back to artificial intelligence and AI, talk a little bit more about that, and hopefully towards the end of the session, you'll see why exactly I believe this. Now, in the past 5 years, as I've leveraged artificial intelligence technology, I've realized two main things as I've implemented it in a wide variety of different fields: healthcare, education, security, and so much more. I've realized that, first of all, artificial intelligence is severely underutilized. There are many use cases where artificial intelligence still can be applied, and there's a lot of scope for its implementation. And one of the reasons that it's so underutilized is because I personally believe that artificial intelligence is by far the most misunderstood technology in the world. Now, what exactly do I mean by the most misunderstood technology? Well, I feel like instead of me having to describe it to you, it's better for me to show you an example of what I mean by misunderstood. Now, this is Sophia the Robot. Occasionally, when I go to an event and I show Sophia, I'll ask a question like, who here knows about Sophia? But I find it's a lot more effective to say, who here is not aware of what Sophia the Robot is? All right, a couple of people, but the vast majority of you know what Sophia is. Now, Sophia is a really realistic humanoid robot developed by Hanson Robotics. Now, this robot is hyper-realistic, and you'll see what I mean in just a moment. A little while ago, Sophia was in an interview, and Sophia was asked the following question. Well, it was really the trolley problem. Who here has not heard of the trolley problem? The moral, ethical dilemma? All right, so the trolley problem is quite simple. You have a train on tracks that's out of control. If you do nothing, it's going to hit 5 people, and those 5 people will die. But you have a lever, and if you hit the lever, the train will switch tracks and it'll only hit a single person. So only one person will die. Now, do you hit the lever? Technically, I mean, it makes sense. Only one person should die instead of 5, but then you would be responsible for killing those 5 people. And, well, instead of me telling you my opinion on the problem, how about we get Sophia's opinion instead?
If this is all the information I had, I would definitely not pull the lever. There might be other unknown complexities in the situation. Plus, it does not seem right to consider human lives as a simple arithmetic problem.
Now, what you just heard from Sophia, if you take a look at the comments on this YouTube video, people are treating Sophia as realistic, human-like intelligence, and this is exactly the problem with not artificial intelligence, but rather the way artificial intelligence is portrayed. What you heard was a scripted response from the teams at Hanson Robotics. Sophia did not synthesize this response. The questions were provided to the team at Hanson Robotics before the interview, and they scripted the results. Sure, the speech synthesis was powered by deep learning, but there's no human-like intelligence behind this. As a matter of fact, Chris, who's helping us out with the live stream right now, just yesterday, this is a really fun story, we were testing out the audio and the video in the amphitheater, making sure everything's working all right. And I played this video, and Chris's first reaction was, that is really creepy. See, that's the problem. We view this as human-like intelligence, even though it's not, and that's what we're going to be talking about today. But that's not just all. There are all sorts of questions that people have around artificial intelligence technology. As a matter of fact, I've put together a few of the video questions that TechTime viewers sent together for us to see and for us to touch upon today.
Hi, my name is Gianluca, and my question is, how will IBM's AI technology and AI technology in general help change the world in the next 10 years?
Hey, it's Ananya, IBMer. First, people were super interested in deep learning, and now it seems like people are super pumped about reinforcement learning and all its possibilities. I was wondering what you think are new fields within AI, or artificial intelligence, that would be important for us to learn about or be aware of.
Hi, my name is Abdi, and I want to know how artificial intelligence can help disable people.
Hello Tanmay. Nowadays, recommendation systems, data analytical platforms, etc. are utilizing one's data. Is it not true that it will be a big privacy breach in future?
So there are all sorts of questions we're going to be answering today, but just before we begin, one last thing I want to share. So a little while ago, I sent copies of the 3 tech books that I authored last year to a girl in Switzerland. Her name's Aria. And now she's one of the youngest readers of my books. But here's the interesting part. You see, her mom rarely allows her screen time to watch TV while she eats or things like this. But a little while ago, she was allowed a little bit of a special treat. She was allowed to watch one of my keynotes while she ate. And I personally feel like I could not describe the point of today's session better than Aria does in this clip here. Let's take a look. Oh, let's see. Why are we not getting audio? Are we routing audio correctly? Let's see. Technical difficulties. Seems like we're not getting audio. Well, all right. I really wish you could have seen this clip. But anyway, in essence, towards the end, what happens is, actually, you know what? There is another way. MacBook Pro speakers are powerful enough for this.
I stumbled upon a documentary. Not just any documentary, but a documentary of IBM Watson playing and winning the Jeopardy game show back in 2011. Best human competitors on that game show.
Right, so that's the point of today's session. I don't want people to view artificial intelligence as creepy or weird. I want them to view it as cool. And so now, without any further ado, it's time to call up my mentors, IBM fellows and CTOs, Rob High and Sam Lightstone. Thank you. Round of applause for Rob and Sam. Thank you. Thank you very much. Thank you.
Yeah.
All right, welcome. Thank you very much for taking out the time. This is really exciting. And really, again, the goal of today's session is to demystify artificial intelligence technology. So now I want to start off by talking about really some of the common misconceptions that people have around artificial intelligence technology, right? And so let's start off with a question about jobs, right? So this is the one question that a lot of people ask most about AI. And that is, well, isn't it going to take away all our jobs? If artificial intelligence scales exponentially in the future, isn't it going to take away all our jobs? So Sam, I believe you wanted to answer this question.
Yeah, I want to answer this question because it's actually the most common question that I get. I get this question all the time. It happens so often that I decided to put some of my own research time into it and think about it and look up some data. And I've come to a personal conclusion. I don't know if all I can say is it's my own opinion, but I have put some research into it. Let me just start with one anecdote. When I was an engineering student in electrical engineering at Queen's University, I had to take a course on It's called The Engineering Society. It was all about the moral obligations of engineers to build things that don't break, lives are at stake, and so on. And one day, the professor stood up and he said, because of all this automation, AI and other things, it's obvious that just all the jobs are going to be automated away, and we will need to shorten our work week from a 5-day to a 4-day to a 3-day, maybe even a 2-day work week because of all the automation. And every night when I'm up at 2 a.m. working for IBM, I think about that guy. What an idiot. So what did he get wrong? What did he get wrong? So as I thought about this, I started to look up some facts. 243 years ago, something magical happened in the world. James Watt invented the steam engine. The steam engine was an amazing innovation because it brought power, mechanical power, wherever you needed it, and it fueled the Industrial Revolution. Before that, you needed a mill, a windmill, harness an ox. It powered the Industrial Revolution, and many jobs were lost, but many new ones were created. And that's the interesting thing. Then I looked up some other data. And the unemployment rate in North America. Look up the unemployment rate actually in the USA for the last 71 years. There's data online. The unemployment rate 71 years ago was 3.6%. The unemployment rate in America, October 1st, was 3.6%. And in fact, although the unemployment rate has been going up and down, it's actually been steady at just under 6% for the last 71 years. So even though the pace of technology has only accelerated, and many jobs have been eliminated, the unemployment rate did not change. So what we see is that automation, if you look back over the last many hundreds of years, 400 years ago, most of us would have been farmers, fishermen, weavers of cloth. Many jobs were eliminated, but many more were created. And this is, I believe, exactly what's about to happen with AI. Many jobs will be eliminated, many new ones will be created. Most likely there will be more created than those that are replaced, because that has been the pattern of what automation has created, the impact it has on the economy over the last several hundred years. So that's my viewpoint. Yeah, there's going to be a huge number of us who will lose our jobs, but many more new, exciting jobs will be created as a result. One of the most interesting of which, of course, is the role of the data scientist.
And I would, if I could add to that, I think that there's also another more subtle activity occurring here as well, which is it's not even strictly about whether people lose their job, it's whether what they are doing in their job changes. Right. And I do believe that we are constantly influenced by the introduction of new technologies which evolve the way that we get things done. And you were talking about your aversion to the term artificial intelligence. My personal one is that the term artificial intelligence places too much emphasis on the idea of recreating and replicating the human mind as an intelligent, sentient thing, as opposed to focusing on how do we augment our own intelligence. This is really technology that's intended to allow us as human beings to exercise our natural intelligence and to be able to do things better, faster, with more effect. And that should be our focus. I prefer the term augmented intelligence than artificial.
Augmented intelligence. As a matter of fact, to sort of add to that, in a way, as you're right, I mean, Sam, you're completely right. Both of your points are correct, that a lot of jobs will be replaced, but a lot of better and higher value jobs will be created. There will be whole industries in the future that we don't even know will exist yet. And if you think about it, a lot of the jobs that AI is going to replace are jobs that don't have immediate or direct meaningful contribution to the long-term sort of benefit to humanity. Right? And the idea is that by creating industries and creating jobs that do benefit towards that, we can have people sort of contribute more towards the future of humanity. That makes a lot of sense. Now, to sort of expand on that, won't it be taking all our jobs? Artificial intelligence is growing at an ever-expanding rate, right? And the point of artificial intelligence, what is it about? It's about understanding data. It's about extracting insights from vast quantities of data, structured or unstructured. That's what's so special about modern artificial intelligence. So then that raises another concern. If we're collecting so much data so we can use machine learning technology to analyze it, so we can streamline processes, isn't that a privacy concern? If we're collecting so much data from users, isn't that a privacy concern?
So, first of all, it's absolutely a privacy concern. I don't know that it's unique to AI, other than AI creates more of an impetus. In other words, because people want to develop AI models, they have more of an impetus to start harvesting all this data. But the problem of collecting data has been around for hundreds of years. The government collects data, your tax data, your all kinds of sensitive data. And that certainly became exponentially worse with the digitization of society. So with the advent of the internet, the World Wide Web, so much more data is online, so much more data is digitized every time you swipe your credit card, every time you use your bank card. But you're right, now there's more impetus. So it's a huge concern. It needs to be very carefully controlled. There's only so far you can go with legislation, but legislation is a start. The problem with legislation is it doesn't help you with the 14-year-old in the basement who doesn't know or care. It doesn't help you with rogue elements or different international organizations who maybe don't feel compelled by your legislation because they're not in that jurisdiction. So there's all kinds of complexities, but certainly legislation is a place to start. But it is a very serious problem.
Absolutely. And in a way, if you think about it, sort of this privacy problem, in my opinion, is also a trade-off. Remember, when you give your data to a company, you're doing it in return for a service, right? You can't have your cake and eat it too. You can't not provide data and still expect a good service. If you think about it, up until a little while ago, a lot of people would complain for Apple's Siri simply not being up to par to Google Assistant or Microsoft Cortana or Alexa. And the reason is pretty simple. One of them, at least, is that Apple simply isn't collecting as much data as other companies. They don't have as much data to train better machine learning-based systems. And because of that, that limits them. And so it's a trade-off. If users find it valuable to give up a little bit of their privacy for the service they're getting in return, they'll do that. And so that's a trade-off that machine learning technology makes.
Yeah, and part of that trade-off also includes how you engineer the systems for collecting that data. Where is the data collected to? And what's done with it once it's brought there. Our mental model is that data is collected from the world, these sensors, microphones, cameras, things that we use, and then all brought back to some central location. And it's there that we do a lot of our training, and then we take the results of that and generate models that we put back out for use in these user experiences. That doesn't need to be like that. There's no reason why, in many cases, as Apple has attempted to do, that the data can't be truncated at the point where the data is being collected, where the data is first being introduced into the system, namely, in the case of Apple, at the smartphone, at the iPhone. And as we get to a world of edge computing where there's more and more compute capacity and network and storage available in the periphery of the compute space, or more specifically in the presence of humans, that the data can be collected there long enough to actually do the training there and then discarded, so that it doesn't travel any further than that, and reduces the vulnerability that might occur if it were to be brought all the way back, say, to a cloud or IT data center. Now, that's not to say that clouds and data centers don't still have an important aggregation role, because if you're trying to do trend analysis or other sort of market level analytics, you need to understand what's going on broadly across the whole world that you're operating with, but you don't need the individual details that might otherwise be considered personal and sensitive data. So mask that data, normalize it before sending it back to the cloud, do that aggregation there, but based on less sensitive information.
That makes total sense. As a matter of fact, what you're touching upon, I believe, touches federated learning and what Google and Apple are doing. For example, the keyboard recommendations that you see, or when you open up iMessage and you type out a message, when you click on the emoji button, you know how it highlights words and says, hey, you can convert these words to emojis. That's powered by machine learning. It actually keeps up to date with different trends and what people are calling different emojis and what they're replacing. And the way it works is federated learning. Apple will send down machine learning models to your devices, train them on the devices with how you specifically use emojis in your messages, and then send those trained models back up to the cloud to be aggregated and sent back to people's devices. So your messages aren't being sent to the cloud. iMessage still has that end-to-end encryption, but some of the important details are encoded within that neural network. So that gets around that privacy problem in that way. But again, at the end of the day, it's a trade-off for users to make. But then, to expand on that point, collecting data, humans are fundamentally biased. Sometimes we don't realize it, but we are biased towards certain things, certain people. And the problem is that that bias shows up in the data we collect, and then that bias shows up in the artificial intelligence technologies that we train. So how can we mitigate that? How much of a problem is that today?
Well, it begins first with what you already said, which is being aware of our biases. And this is part of the problem. I think that for too long, we as humans are unconscious of our own biases, but that same unconsciousness is also permeated into the way that we engineer systems. And so, first of all, recognize that biases are real, they exist, and they exist within all the data that is collected about people and behaviors. And so with that realization, now you can begin to think about techniques for dealing with that, one of which actually is using AI itself, which is really pretty good about looking at patterns and recognizing outliers and distinguishing between normal trends versus abnormal trends. And so leveraging the AI for the purpose of recognizing biases within its own system is actually an interesting idea. And then, but instituting processes that are deliberate about trying to exercise awareness of those biases is also important.
I would add to that a little bit. I agree with what you said, Rob. I would add to that, there's also a bias that comes into AI, not because of our own human bias, but a bias that's actually perhaps present in the data. So for example, you can imagine if you're collecting data samples of certain populations, you may just, by happenstance, fall upon a data set that has more of one gender than another. So for example, in my engineering class, it happened to be we had more males than females. My wife went to a nursing school. It happened to be there were more females than males. Okay, so if you were to do build AI models based on these very skewed data sets, you would have a gender bias in your model. That's not a bias that comes about because of a human error.
Yes.
It's a bias that comes about because the data itself was skewed. Data skew is not an accidental thing. Data skew is everywhere. It's unusual to find a data set that doesn't have skew. Most data sets have some kind of skew in some dimension.
Yes.
And so that's a real problem. It's not a human problem.
Yes.
One of the technologies we've been developing at IBM is called Watson OpenScale, which tries to automatically detect these kinds of skews in the data that are relevant for the model that's being generated and inform users, data scientists, that there is skew in their model, and the source of that skew is because the skew has arrived in the data set that they use. So we are working on technologies to detect this kind of skew. It's very important. But these two things together really represent a two-edged sword that is deeply problematic.
Absolutely.
Yeah, and just follow on one other point here is that some of the skews start to surface after the fact. Even if you have a perfectly normalized and regular form of data, you've gone to the effort of making sure that you've reduced any skew that may exist there. Then you deploy a system that continues to collect data. As you said, these skews are often the result of just how human populations aggregate, and if they aggregate in one way or the other in the use, then those biases may start to flow back into the system. So it's not even something that you should do the first time you look at the data. It's something you need to do on an ongoing basis.
Absolutely, absolutely. And bias, again, is not even limited to just human things like gender or race, as a lot of people think. Bias is really, as you said, Sam, more generic to data. I mean, you could create a neural network to predict whether a jet engine's going to fail. It might be biased towards GE engines versus Rolls-Royce engines, right? It's not just towards human features or attributes. It's generic. It's a problem with artificial intelligence technology today and how it works. And so this actually leads me to my next point. Artificial intelligence technology, one of the reasons it's so biased is because, again, it's not like a human. It doesn't think. It is mathematical, purely mathematical. And so what really is the difference between artificial intelligence and human intelligence? Now, before we answer that question, one thing that I want to mention really quickly is that for the live stream and everyone in the amphitheater, we will be having a Q&A session after this in the next few minutes. So if you have any questions, feel free to ask them on the live stream. My mentor, Steve Martinelli, is going to be helping us out and giving me questions. And in the amphitheater as well, just raise your hand, we'll get a mic to you and we can answer your questions. But yeah, so the difference between artificial intelligence and natural human intelligence. If you think about it, really, in my opinion, machine learning technology, at least modern machine learning, say deep learning, while on a high level, some of the nomenclature and some of the structures are highly inspired by biological neural networks, at the end of the day, the way it works is entirely different. It really has no resemblance to the way that humans or animals think, really. And so that's one of the main differences between the way artificial intelligence works and the way that human intelligence or natural intelligence works. But the problem is that because of the way that neural networks or deep learning systems perform, because of the way they behave, and because of the way they're presented in packages like, for example, Sophia the Robot, it's difficult to make that distinction. So what are your thoughts on the differences between AI and natural intelligence?
Well, let's start with what the similarities are, and you've touched on some of this, but I will highlight for people that one reason why people get confused by this is they always want to map it into something they're familiar with.
Yes.
So we see something like Sophia or Pepper or any of these other examples, And we immediately leap to assume that that must be very similar to us. And so we project on ourselves our own expectations about that intelligence. And when it's close enough, we just sort of say, well, that must be like me. But one of the things that I think we must come to understand and embrace, because I think it's a positive thing, is that the state of the art of the technology today is primarily focused on recognition problems.
Yes.
You know, we've gotten very masterful at using AI machine learning for doing great things with recognizing, visually what kinds of images we're looking at or what kinds of things are occurring in the image, auditorially, what the sound is and things like that, or across the data set, what the patterns of meaning are within that data set. But that, in human terms, is a small fraction of what we do. Now, we do a lot of it.
Yes.
We're constantly bombarded with things that we're expected to learn how to recognize. Most of that's been done subconsciously. But that's inductive reasoning, right?
Yes.
It's recognizing things that we already know about, and recognizing whether what this is really something that we've already been taught to look for. It's not deductive.
Yes.
And that's, for me, is the number one biggest difference between artificial intelligence and human intelligence, is it doesn't have any ability on its own to form its own reasoning plans and strategies, and to take that then and formulate an opinion, which then further gets to another aspect. It has no abductive intelligence either,
Yes.
abductive reasoning capability either, which is this ability to learn on its own new theories about how to reason deductively. Scientifically, I think that's the biggest difference, is that AIs have only touched, one of the three major types of intelligence we can associate with humans and animal species, but even that is a fairly low level of complexity as compared to the complexities of human deductive and abductive reasoning.
Let me play devil's advocate a little bit. I think part of the excitement around AI, the power of AI, is it is increasingly doing so many things that we do legitimately associate with intelligence. You think about AI beating the Grandmasters of chess. We think of chess as being, a great intellectual pursuit of strategy and memorization and tactics, and the best chess playing programs of the world now far exceed the chess grandmasters of the world, the human grandmasters. AI is now being used, or is now capable of doing artistic activities, art, music, creating original compositions. These are some of the highest intellectual pursuits of humanity that AI is now embracing. And most of this, I think one of the most important aspects for us to reflect on, most of this has happened just since 2012.
Yes.
Right?
Yeah.
And if this is what we've accomplished in 7-8 years, oh my God, what's going to happen in the next 20 years? So don't kid yourself. So in terms of emulating intelligence, let's separate simulation and emulation. Emulation is creating the effect, regardless of the mechanism behind it. But the emulation of intelligence, there's an argument to be made that it's coming along.
It's progressing. It is. I think the point, though, is not whether it will progress, number one. It will likely progress. But secondly, where will it end up? And of course, how far we progressed on that line. But I think we also have to factor in the same thing that we talked about earlier, which when we were talking about replacing human jobs, the underlying force that shapes what it ends up doing are economics. And you got to ask the question at some point, what's the economic value in replicating the human mind? Not that it is an interesting academic pursuit, but from a societal standpoint, is it a technology investment that human society is going to continue to invest in if the end result is only to create other things that are just like us?
Yes.
And
we have enough of us.
Well, first of all, I'm not sure I want to. There's plenty of us, but also there's more interesting ways of creating that. More of us. And we also have a lot of flaws. But in all other examples of technological advancement and its influence on society, we've always shaped these technologies around things that augment us. I will also point out that human intelligence, number one, we measure actually in artificial terms.
Yes.
We create these measurements of what we think is intelligence. The IQ test, for example, is somebody, a set of intellectuals that got in a room someday and said, well, this is how we're going to judge whether somebody's intelligent or not intelligent. But yet, if you really kind of get down to human experiences, there's many different dimensions by which we can evaluate and value our various types of intelligence. But all of that intelligence was a result of human evolution. And human evolution shaped our intelligence to have a certain form as a consequence of what it took to be able to survive. You had to learn how to react quickly to the rock being thrown at our head, right? To avoid getting hit and potentially getting killed. And in doing so, we formed the ability to recognize things very, very quickly. Or we learned how to reason about how to get out of a problem because the tiger was coming to get us, and we had to go figure out how to get out of the back of the cave somehow. So these forms of intelligence were the consequence of literally millions of years now of evolutionary forces that shaped our particular kind of intelligence. And there's nothing to suggest that artificial intelligence, machine-based intelligence, will be subject to the same forces.
Absolutely.
So it's likely to evolve subject to the forces of economic interest. More so than academic interest in replicating human minds.
But maybe if I could just, as a related tangent, state what I think is really the great value of all this, the great value of machine learning. In somewhat related to this topic of whether it's real intelligence or not real intelligence. There's a beautiful little discussion on the internet, on YouTube, you can find between Andrew Ng, who's a AI researcher at Stanford, very famous, and Geoffrey Hinton, who's the godfather of deep learning at University of Toronto, here in Toronto. And the two of them have this beautiful discussion. And in the middle of the dialogue, Geoffrey Hinton says, the big inflection point is that with machine learning, we show the data to the computer and it learns from those examples. And so think about that. For the last 50 years, we've programmed computers in a very functional, programmatic way. If, then, else, case switch, do this, do that. All these programs we've developed for the last 50 years were limited by our ability to express logic and strategy in that very mechanical way. The big inflection point is that using machine learning methods, we can now essentially program computers by means of example. By showing lots and lots of data points, and then the computer learns. And that allows us to effectively program things that are far more sophisticated, far more dynamic than we could do on the old functional model, if then else. That's why AI and machine learning is able to do things that we couldn't do before. Is from the example of the data rather than if then else. Okay? That's the big inflection point. That's really, it's all computer science. It's not so much about, is it true intelligence, it's about learning from the data.
Absolutely. And to expand on that, that's a really good point to end off on. And Rob, I love your unique take on how AI is going to progress. Like, it's about economic gain. It's about what humans want AI to do, not necessarily what's academically possible, right? And to expand on your point a little bit more, Sam, of how we're able to teach computers by example, the way I like to sum it up is this. If I give you 10,000 or say a few hundred pictures of dogs and cats, and I ask you to write a bunch of if statements that say, all right, look at every single pixel and tell me if this contains a dog or a cat. It's next to impossible. It is impossible. Because while we as humans have the ability to just look at an image and instantly recognize what's in it, we don't understand how that capability of ours works. We can't quantify it mathematically. And because of that, we couldn't impart those abilities into computers because we have to provide them with that list of detailed instructions on how to do that. But now with machine learning, we don't need to. We just provide it with the data, and function optimization takes care of the rest. And Rob, your point actually leads me into something that I'm personally really fascinated by. And it's more around the psychology of not just, the fact that humans perceive AI as human-like. Even, when it's packaged like, for example, Sophia the Robot or Pepper, people view it as human-like. But why do they do that? What is it about human nature that makes us think or see AI in such a human-like way? And in the research that I've done, I've found that really, at the end of the day, artificial intelligence like this is essentially an illusion that's propagated by the false representation of artificial intelligence. I mean, think about it. NASA takes pictures of different craters on Mars, and people see faces in those craters, right? Because our brains overfit to seeing certain things in certain places, even where they don't exist. I mean, think think about it. In the wild, it's really advantageous to be overfit to seeing faces everywhere, even where there are none, because it can help you with cooperation with other humans.
Yeah, it's the evolutionary effect.
Precisely, the evolutionary effect that you were just mentioning. And then it's also very advantageous to just assume that there's life or intelligence everywhere, because if you assume that, then you can take the sort of worst possible future scenario and move along with that in mind, right? And the thing with artificial intelligence is, remember, humans didn't evolve for millions of years in the wild with technology. Technology is a very recent invention. We have not given nearly enough time for natural selection to help us create new centers in the brain that deal with technology. I mean, we had to give up a lot of our short-term memory from our last common ancestor with chimpanzees in order to even make space in the brain for language. So there is a lot of room for improvement still with our current brain and our modern technology. But what happens is, even when you use a computer, it's been proven by MRI scans that your brain is reacting to interacting with that technology the same way it interacts with any other, or the same way it reacts with any other kind of social interaction. You could be interacting with your pet or with another human, and your brain will react the same way dealing with a computer. I mean, linguistic psychology is a perfect example of this. If you wake up one day early morning for a call and your computer crashes just before you're able to join, you might say something like, "My computer isn't cooperating with me," and go about your day as if nothing happened. But from a linguistic psychology perspective, that sentence is worth spending years studying, because you said the word cooperating. My computer isn't cooperating with me. That doesn't seem like a lot, but the fact that your brain chose to use the word cooperating is incredible, because that implies that your brain is using centers of the brain that imply something that's thinking, hey, I don't want to cooperate with this person today, right? So your brain doesn't realize that difference between inanimate and animate, even though you consciously recognize it. And that subconscious bias is what leads us to see artificial intelligence as intelligent, even if it's not. Even the best of us, right? Even as long as you're a human seeing technology like this, your subconscious mind is pre-filtering and biasing that data, whether you like it or not. I mean, take an optical illusion, for example. You cannot tell your visual cortex, I don't want to see the optical illusion because I understand it isn't moving, or I understand the two lines are the same length. Your visual cortex is biasing the data, and that's it. Your conscious mind is given that data to work with. You can't control it.
It's the same thing that leads to that sense of creepiness that you referred to earlier.
Uncanny Valley.
That's what psychologists refer to as the uncanny valley.
Yes.
It's your subconscious mind being able to sense the distinction between a real experience versus one that has been close, but not quite the same.
So that's sort of what I've found in terms of why people view AI as human-like. Is there anything that you've noticed in the field?
Well, I would add, it's a small point perhaps, but you made the distinction earlier about machine learning and AI. And I think in computer science, these words have sort of a scientific ways in which they are differentiated one from the other.
Yes.
Okay. Whereas machine learning is about algorithms, AI is about emulating the perception of human intelligence. But that distinction between the algorithms and the emulation of what the human mind does, it seems like it was just too subtle for society, right? So all the journalists, all the columnists, and all the business people just didn't get it. So they said, we'll just call it all AI.
Yes.
And once they started calling things AI that were really just machine learning algorithms, that has fueled a lot of this misconception.
Yes,
that's
absolutely.
Right. Yeah, I think the media plays its part in this. And I don't blame the media, because I do believe that, some of this stuff is too complicated for the average person to get to understand the subtleties of, and so it's just easier to convey things in forms and in terms that we're familiar with, and to say that this thing is intelligent is easier to say than, it uses a neural network and machine learning and all the other details that go into that. So I think that media, portrays and amplifies the perception that these things are attempting to emulate the human mind. But I also think that, that to some extent, because a lot of people, like you said, come to me and ask me about where this stuff is progressing, and a lot of it is based on some underlying fear that somehow these AIs are going to rise up and occupy our world and take over the human population. And I think there may be even a sense of guilt in there somewhere that people maybe don't feel like they deserve to exist in this planet or something. But I also think that I'm less concerned about where AI may take itself than I am about how humans apply AI in the world that we operate in. I'm more worried about the people human beings I am about the technology. We have to adapt to the technology. We have to learn how to harness it. We have to apply it to reasons that are useful and productive for us. But we also have to guard against people abusing it, exploiting it, and misrepresenting it.
Absolutely. I mean, you mentioned misrepresentation. That's exactly what I think this sort of artificial intelligence thing is. Now, I do want to make sure we have enough time for questions. Yep. But one more thing that I want to mention really quickly is sort of the consequences of the false representation. What drawbacks do we have in society because of this false representation of artificial intelligence? And I mean, there can be false representation for all sorts of technologies, but I feel like for AI, it's at a scale that I haven't seen with any other technology so far because of fundamentally what the technology does. I mean, the Apple Watch does fall detection. I could fall on stage right now and it'd say, hey, you fell. If you don't respond in 60 seconds, I'll call emergency services. And that's really useful. Everyone calls it machine learning. But then right as you take the same fundamental technology, the same backpropagation, the same neural networks, and when you put it on Sophia the Robot, or Erica the Robot, or Pepper, apparently everyone starts calling it artificial intelligence. So it's really that perception of the technology and the false representation of it rather than what it's actually doing. So what are some of the consequences of that false representation you've seen in the industry?
I think the danger is that society, human beings, as a natural consequence of our psychology, get desensitized to the dangers.
Yes.
Right? And back to our early comments, we need to be concerned about how this technology is being applied. We need to recognize when our data is being exploited and potentially abused. We have to worry about whether our privacy is at risk. And if we get too comfortable with the fact that we were worried about this technology and it turned out not to be a problem, and take that to mean, well, we don't have to pay attention to it, then we've gone too far, right? We do need to stay conscious of the dangers and make sure that it's being applied in appropriate ways and that we're accepting that use in ways that we find reasonable. And if we continue to be exposed to misrepresentation that doesn't really materialize, then it's too easy for us to say, well, I don't have to worry about it.
Absolutely.
Yeah. I would add a couple of points. First of all, on the consequence, and second of all, on actually the benefit of the misrepresentation. One of the consequences, of course, is that we just trust it too much.
Yes.
That's a huge risk. So we just start trusting all this AI and it's actually not so trustworthy because it's got bias or because it's inaccurate or whatever. But there is a benefit to this misrepresentation.
Yes.
Which actually you're seeing in the industry right now with many CEOs, including our own Ginny Rometty, calling for careful legislation and control of AI. That's actually healthy because it means that we will take seriously this problem, the problem of AI being over-trusted and misused, and we'll begin to start working on that problem now, maybe a few years even before it's necessary. That's, I think, actually quite healthy because you don't want to find yourself 20 years down the road where it's maybe infused itself into too much technology and it's a little too late to slow it down.
Absolutely.
You want to get going now on making sure that these technologies are not abused.
Absolutely.
So there is a subtle benefit in all this, aside from the risks.
I do agree. There is a subtle benefit, but I do feel like it's important to make sure that, in a way, artificial intelligence isn't misrepresented in a way that calls for regulation or legislation that stifles innovation. That's my opinion on the matter. Most certainly it is important to be careful. It's important to make sure that you're future ready, but at the same time, we don't want to make it so that people that are in charge of making decisions don't know how the technology really works. And because of that, they introduce regulation or legislation, as has happened with many other technologies, that doesn't make sense.
Yeah, I agree.
I think it's what Jenny refers to as precision regulation.
Right.
Yes.
That's always the challenge in any regulatory process, is making sure this is solving for the real problem as intended and not creating unintended consequences.
Absolutely. So now I do want to open up for questions, but really quickly, there are going to be some questions that I ask you. We're going to have really quick answers to them. These are some questions that we have touched upon a little bit, so maybe we'll skip one or two of them. And these are questions that a lot of people are really interested in knowing about. So first of all, what are some new machine learning architectures or technologies that are interesting? We saw one of the questions was, people have been talking about deep learning, talking about reinforcement learning. What's next? What are the new architectures people are talking about?
Well, one of the interesting ones that's really emerged in the last year is the GAN.
Yes.
Right? The generative adversarial network.
Yes.
Two networks fight each other and train each other.
Yes.
And in so doing, can be used to create actually be a creative process, not just an analytical process, an optimization process. The famous example, again, you can find on YouTube is where GANs are being used to generate faces of human beings that have never really existed. It's trained originally on a database of celebrity photos, and then after studying those celebrity photos, it begins generating human beings. And what's really amazing, you watch that video, it's not just the faces that are being generated. It's the clothing, the jewelry, the hair, the hairstyles.
Everything around.
Everything. It's like you can see every whisker on the guy's face. It's actually quite remarkable, so I recommend looking it up. But if that can be used for generating photos of humans that never existed, in principle, I think it can be used for many, many other things. Creating art, creating music, creating all kinds of poetry.
Well, and simulations, it's one of the things that we all need is more training in whatever craft we're responsible for. And if we can create an artificial training environment that's pseudo-realistic, it may allow us to train better.
Yeah.
The other one that I like right now, especially since I've been doing so much work in the world of edge computing, is federated learning. We're applying edge computing to bring AI and analytics and machine learning, and of course procedural programs as well, out close to where data is generated and where actions are taken. But that also means that we're dealing with much smaller computers, we're dealing with large numbers of computers, and trying to get a community effect out of that is a really powerful idea.
Absolutely. In my opinion, natural language and sort of next generation natural language understanding is something I'm personally very interested in. I feel like not enough work has been done in that area of AI, which is why I'm really interested in the work that IBM Research is doing with, like, for example, Project Debater and argument mining. So that's a really good idea. So GANs, federated learning, and in my opinion, next generation natural language understanding with deep learning technology. All right, so those are some of the questions that people had. Thank you very much, Rob and Sam, for your opinions on these different talking points. And now, we have 10 minutes left, 12 minutes. And so if anyone has any questions on the live stream in the amphitheater, feel free to raise your hand. We'll get a mic to you, and we'd love to answer. Yes, in the back. If you could just speak with the microphone, because then we can have people in the live stream hear your question as well. Thank you.
Hi, thank you for a wonderful, introduction on things. So my question is, regarding this job market. Like, I'm not looking at, let's say, positive or negative aspect of whether people lose their job or not. Of course, I would be myself worried and will be worried about people, let's say. But regardless of that angle, when we look at, let's say, industrial revolution, which happened, a lot of people moved from their physical ability to have an intelligence job. So humans have these two broad, abilities: physical ability compared to apes, and let's say intelligence. So when the physical ability was replaced by intelligence, we moved to have intelligent jobs. But now with AI coming, slowly, we are creating things which will compete with us, And so whether it's good or bad, that's different thing. But don't you think that will intensify the competition, and we still have to invent like what sort of more intelligent job we'll do? Sure, right now we can do, but as time goes on, what are your thoughts on those?
Well, I mean, I guess I'll start. So one thing that I will mention is that you're right. We've gone from selecting humans for physical ability or selecting animals for physical ability to selecting humans for intelligence. Right? If you take a look at us, the only thing that we really do special that physically is that we can grasp things intricately, and we have good control over our fingers and things, and we can run for very long periods of time. Not necessarily fast, but we can run for very long periods of time. Those are really the only things that set us apart physically. Apart from that, the only thing that really sets us apart from other animals is our intelligence. And now, with the kinds of technology we have, we're starting to select humans more and more for their intelligence and less for their physical ability. You're right in saying that. Now, if I got the second part of your question correctly, then you're talking about if we have technology that itself is intelligent in a way, then it's competing with humans as well, and we're selecting for higher and higher needs for intelligence. And you're right, that's exactly what I'm talking about. Humans in the future are going to need to evolve according to the jobs and things and the tasks that we have to do. Remember, we evolved to be humans because we had different tasks to do than we evolved to do, therefore we were selected to do certain things. And that's going to be exactly what happens in the future. If there's certain jobs that need to be done, then we're going to select for humans that can complete those jobs in particular, and jobs that are no longer needed, well, we don't need those kinds of humans anymore in a way. And so really it's about not an overnight transition. This is something that's going to happen over many years, decades, as artificial intelligence technology slowly becomes more and more advanced and starts to be applied in more and more areas, more and more industries. It's not something that's going to happen instantly, and we will have time to adapt to that. We're going to have time to see that coming and change the way we, for example, educate people to make it more efficient, to make it so that they can enter these jobs that have higher value. For example, while I can't, of course, speculate on future industries that don't exist yet because, well, they don't exist yet, I can say that, for example, there's a large lack of people in the field of healthcare. Over 12 million people are going to be required by 2030 in order to keep up with the growing demands of the human population for healthcare. And the problem is that if we have people working mundane jobs, like, for example, driving trucks or driving cars, or for example, one more thing, people mentioned that, hey, if we have self-driving cars everywhere, the entire driver's education industry is going to go away. Well, think about it. If it goes away, we have millions of people that can be now reapplied in the field of healthcare instead. And so as we start to see these changes coming over the next few years, we'll be able to adapt systems like the education system in order to prepare people for the future in which only that set of jobs is available. That's my opinion. What do you think?
Yeah.
Sorry, go ahead.
Well, I'd like to make an even more practical point, which is that when you made the point about people being selected for the intelligence, one of the intelligence characteristics that I think are often make us as humans competitive is our ability to learn about tools and to use those tools and exploit those tools as part of our productivity. And if we think about AI primarily as a tool, then the challenge is how quickly can you learn to use that tool to give yourself a competitive advantage. And I think that's probably a much more practical way of thinking about the problem than to worry about whether the AIs are ever going to grow up to completely replace what we do as human intelligent beings.
Yeah, one of the business catchphrases I've heard along those lines is, AI is not going to replace humans, but people who use AI may replace humans who don't.
Yeah.
So, this is just one of the modern tools. We all learn to use a calculator, right? We all learn to use a laptop computer. People should start to learn to use AI. I also want to ground this thought a little bit because there's so much hype and excitement around AI, which I actually think is warranted in many ways. But let's also be realistic about, the maturity of all this. So first of all, at least 80% of the AI that people talk about is not deep learning and reinforcement learning or any of those things that's used in actual business applications. Probably 80% of the real business applicable AI is classic machine learning. Like random forest and k-means and linear regression and logistic regression, all that classic stuff, it's got nothing to do with deep learning. That's 80% of what's going on in the business world today. And if you think about deep learning, here's a very interesting thought experiment. You mentioned it before with the cats and the dogs. You show a human being a photo of a cat. You see a photo of a cat, you say, okay, that's a cat. Now I know what a cat looks like because I saw a photo. But a machine learning algorithm needs to see 100,000 photos of cats. 100,000 photos or 1 million photos before it knows what a cat is. So there's no comparison, even in the deep learning trained with a fleet of GPUs, it's still very far, far inferior to what human beings are capable of. So we're quite a ways off. The hype is one thing, the cutting edge science, it's fascinating, we should follow it, and it will mature. And it will become something great, I'm sure, one day. But we're still in an era where this is the infancy. Most of what we talk about in AI has evolved, for the most part, since 2012.
Thank you. Hope that answers your question. Do we have questions from the live stream?
Yeah, we do have a few questions from the live stream. We've got, I think I'm going to ask 4. One is probably more specific for you, Tanmay. We'll start off with that one there. What are some resources that someone can read about AI online if they're, 14, 15? How did you get started?
Well, the way I got started was through Watson. So I started off with the Watson APIs and just really calling the REST APIs and figuring out how it works. But if you want to have a more structured approach to sort of getting into the world of machine learning technology, there is a platform that I actually work on. The platform is called Cognitive Class. CognitiveClass.ai is the website. It is a skills. It's a course platform where you're going to find courses on all sorts of different topics, from generically getting into languages like Python, using different Watson APIs. In fact, I actually have a course on there now on the Swift or TensorFlow language and how you can do things like reinforcement learning and Monte Carlo tree search and all these sorts of interesting algorithms. So cognitiveClass.ai is a good resource to get started with AI.
All right, we've got 3 more questions here. Maybe each one of you can take one. Do you think whoever wants to take one, go ahead. Do you think the general population overestimates or underestimates the capability of AI?
I feel like we all have a bit of an opinion here, so we'll go one at a time. I personally think they overestimate what artificial intelligence can do in some areas, but in other areas, they underestimate what it can do. And that's again what I'm talking about, the misrepresentation of artificial intelligence.
Yeah, most people I meet are quite dismissive of it. They don't think it can do very much. They far underestimate what it's capable of today and far underestimate what it will be doing in the future. That's why there's so much hesitation around self-driving cars. People say, I'm not going to trust that thing, right? And especially for people who are not, it's one thing in this audience, we're dealing with people who are tech savvy. But outside the tech community, a lot of people are very dismissive of the whole thing.
Rob, do you have
No,
want to add to this?
I wouldn't say anything different. I mean, I think the general population exhibits a great deal of fear about it when they're not being dismissive, but I think that fear is unfounded about the technology. As I said before, right? People should be more worried about how other people are applying the technology and what it's doing to them, but the technology itself is not the fear that I think most people have.
Mm-hmm.
And the last question, it's kind of a two-parter. 2 different sectors. Some people were asking about how can AI be used in different fields, specifically in terms of helping out with climate disasters and helping out with law, being a more fair judge and jury. So kind of a two-parter there, 2 different fields.
Let me start off with at least the weather-related one. So I think one of the great opportunities that is starting to surface now is applying better weather prediction to micro decisions. We've always used the weather predictions on a fairly broad brush, and we know that it's going to be snowing in the next couple of days, but we don't really know exactly where or how much, and we don't really need to know how to put that into the day-to-day, minute-by-minute decisions. But for example, we're working with some of the logistics companies to help their delivery drivers make better decisions about how to route the delivery process that factors in knowledge about what's going to happen at the intersection of the town, where if there's a rainstorm, it tends to flood and back the traffic up. And so by understanding that dynamic between where it's likely to rain, what that impact is going to have on traffic, the drivers can do a better job of routing around that, not only making themselves more efficient, but having environmental benefits as well, because they're not sitting there idling in traffic the whole time. That's an example. Seeing farmers doing the same thing when they're looking at when and where to harvest in individual parts of the field, how much of the field to actually take, because it can be compared now to the cost of drying that grain or whatever. These are the kinds of detailed decisions I think that better weather prediction based on machine learning and machine learning will be able to do to benefit decisions that are made.
Yeah. I think there's almost no industry that's going to be unaffected by AI. It's going to be everywhere. It's already pretty heavily used in legal. I think it was one of the examples that was asked about was legal, medical, you name it. It's being used. I think any place you're talking about looking at trends, analyzing trends, either to infer or to predict, it's a clear case of opportunity. Now, on something more subtle like can a judge be more fair? That's obviously a much more sophisticated level of reasoning that's involved. I'd like to suggest, I don't think we have AI today that you would ever want to use in place of a judge. Okay, it's not even close. We're talking decades, at least decades away. But it's an interesting metric that was told to me about some of the work that Rob's team did when Rob was leading our Watson group. Like Watson could read 30,000 medical research papers an hour. That's a number someone in IBM Research told me. How many research papers does your family doctor read a year? So where these AI systems can be effective is if you're a judge and you want to know what case law may be important to me as I'm adjudicating this case. Yeah. Well, an AI system can pop up immediately, with this vast understanding look, you may want to look at these 10 examples of case law as you adjudicate this case. And a human being may not, even the most brilliant judge may not be able to tap into that breadth of case law so quickly.
And we should be careful with the use of the term understanding. It's not understanding the document and all the subtleties and nuances that, the logic that's expressed in that document. What is understanding is the linguistic properties of that document and the potential relevance of that document to the topic that is of interest. It's, again, a recognition task, right?
Mm-hmm. Yeah. More questions from the live stream or in the audience? Feel free to. Wonderful. There's one from the amphitheater.
Hello. Thank you. So today you guys talked a lot about the public perception of AI or machine learning per se. So my question is based on this. I don't know if you know, but some time ago, not too long, there was a tech talk held in China. And they invited Elon Musk and Jack Ma. So both of them are very famous in the tech world. And they had an interesting debate on the future of AI, one being more optimistic, the other being more cautious. So my question is based on this. So as you guys know, Elon Musk came from a very technical background. He had a degree in physics and some other degrees. And then Jack had a more business, I think, background. So my question is, so I'm not, I don't really have a problem with their either optimistic or cautious take on the future of AI. I think it's good to see things from both perspectives. But my question is, so given that one person is from the business background and he has such an influential power on this world, what's your take on, someone, without the technical knowledge on this topic to give such a, powerful statement to the world? Thank you.
Well, that's a loaded question. It's fraught with all kinds of social dynamics. I mean, let me just make some very quick observations. I think the history of the world, the last 600 years, is this diffusion of power, right? 600 years ago, the world was ruled by autocrats. And a collection of autocrats. It wasn't just one guy, but
we may be getting back there.
We may be getting back there. But autocrats ruled the world 600 years ago. We've moved to a much more distributed, many democratic societies, and even countries that are not truly democratic do have a bureaucracy that keeps their autocrats in some degree of check. So, so that's on the one hand, we have that dynamic. On the other hand, we have this bizarre dynamic, what I'll call the People magazine dynamic. It's like celebrities who really are not necessarily authorities on a particular topic are trusted just because people are their fan. You're a fan of an actor, and all of a sudden you're trusting them on AI and global warming and all kinds of things. It's like, why? Why? Because they're good looking? Why? Because they're charismatic in a movie where someone else wrote the script? Like, really? So that's a bizarre dynamic which I can't explain, but it's obviously problematic if, as a collection of human beings, we believe too much in the opinions of charismatic people. That's deeply problematic.
As a matter of fact, to expand on that, that's the entire point of this series.
It
is to bring you people that are actually working in the field and have been doing so for literally decades at this point, and that actually have firsthand experience building the technology and interacting with people that use it, so you can learn from them instead of from, as Sam mentioned, people that starred in a movie where someone else wrote the script. And so that's the idea behind this series, right? And so go ahead.
If I can make one more point to tie this off a little bit, and that was, if in doubt, don't listen to what people say, listen to what they do. Mm-hmm. And Elon Musk is a good example of this. I think Elon's done some really outstanding things, but he has this very pessimistic view of the future of AI and its potential to disrupt human society, but yet he continues to invest heavily in the use of AI in his automobiles and other products that he creates. So there's a contradiction in that, apparent contradiction, but I think that also informs you. Because if you look at what he's doing, you begin to realize that what he's really saying isn't that AI is bad. He's saying that what people do with AI could be bad, and that's what we need to watch for.
Absolutely.
Great point.
So let's take one more. I think we have enough time for one more. Anything interesting from the live stream? Not at the moment. Not at the moment. Anything else from the app? Yes.
Yeah. So my question is, there's another problem with machine learning that concerns me. Like, I think the technology is based around inputs and outputs, and there's like a huge black box in between that it's hard to understand what's going on, what led to the output from the input. There are a lot of technologies that address this problem, like knowledge representation infused with machine learning. I'm wondering if you guys have any take on how to address this problem.
Well, I mean, I think I'll start off and I'll say, first of all, this is a problem that is pretty, I mean, a problem that's mostly faced by more modern machine learning techniques like deep learning in particular, right? Like, for example, if you take a look at VGGNet, right? If you take a look at that popular convolutional neural network, it's essentially impossible to look at the individual convolutional filters and try and figure out what each filter is trying to look for, right? And that's intrinsic to the way that these neural networks are designed. They're literally just a function optimization problem. There are specific ways to work around the problem, but so far, in my opinion, this is very use case specific. So like, for example, a little while ago, I was working on a neural network around trying to predict whether or not someone has a certain hearing disorder based off of certain features gathered by an audiologist. And the thing about this application is that, of course, it had to provide an explanation to the audiologist of what features made it come to a certain decision, because otherwise the audiologist has to redo that process and kind of make sure that the neural network made the right decision. And in this case, what specifically worked for this problem and the specific architecture I was using was what would nowadays be considered a pretty primitive attention system, right? So literally just taking the inputs, multiplying them by a probability matrix of which inputs have the most weight, and continuing from there, and using that attention layer to tell the audiologist, hey, these are the features I was looking at most. So in a lot of cases, I believe it's use case specific, architecture specific to solve the problem, but there are things that I know people are working on, IBM Research is probably working on, to be able to peer into that black box and try and figure out what it is that deep learning systems are learning. So
yeah, I mean, actually, we've gone much more than just theory. We've actually delivered a product called Watson OpenScale, which is part of Cloud Pak for Data. There's a minor product plug there. But leaving aside the product plug, what these technologies do is they actually give you insight on why the machine learning made the decision that it made. These machine learning models have a collection of inputs that we call features. One of the big art forms of data science is what we call feature engineering, the design, the selection, the shaping of these inputs. What should the inputs be? How should they be structured? That's a huge part of what data scientists do today is feature engineering. That's inputs into the model. Then you have this black box, as you say, and then you have the output. And what Watson OpenScale is doing is it's trying to give you it's trying to open up the black box. That's why it's called OpenScale. It opens up the black box and says, you know why that output was what it was? It was 62% because of this input, right? And by the way, here's the influence that your other inputs had, either for or against the output that was generated. So we actually have a product in this space. Whether it's from IBM or any other company, the idea of having insight to open up the black box and understand why the AI has made the decision that it's made is incredibly important. It's incredibly important because without it, how can you trust the AI? How do you have any confidence that it's done something sensible?
Yeah, so I think that is important, but not because that's the final answer. I think it's important because that's all we have. I will, just to make my point here, you asked a question. If I asked you to explain to me the neural structures that you exercised in your head to come up with that question, you probably couldn't do it.
No, probably not.
If you could explain the neural structures that were exercised there, I wouldn't know what to do with that either. If I asked you to give me the reasoning behind that question, what led you to want to ask that question, you might come up with a representation. It's probably an artificial representation. It's probably not one that exactly captured the neural logic that you went through in your head, because frankly, you probably don't even know. You're probably not conscious of some of the things that fed into that logic. But you can give some approximation, and that's probably sufficient for me to understand then what that means and what to do with it. So I think, as we get better at revealing, quote, the black box, it's not going to be because we did a better job of representing what went on inside it. It's about whether we can come up with better abstractions of the logic that people can reason about and make use of. And we're not there yet. I think there's a lot more work to be done, but that's going to be much more useful for people than simply trying to identify what weights were associated, what input gave more weight to the decision than something else. Because it's just, at the end of the day, it's just too complicated to look at that, and people won't be able to abstract it well enough to be able to make use of it.
Wonderful. I love that point. One last thing I want to mention really quickly. Again, this ties back into linguistic psychology. Language is limited. When you try and come up with that representation of what your mind went through to actually come up with, oh, this question in particular, language is limited. You cannot come up with that exact description of what you went through because you, of course, first of all, don't understand it, and on top of that, your brain can't synthesize that in language. And finally, one more thing I want to mention. What you said here around not just understanding the neural structures, but really understanding an abstraction of why it came to that decision. A researcher a little while ago trained a neural network. This was before, reinforcement learning was popular. This is like behavioral cloning stuff. And he trained the neural network with inputs from an Atari game, and the output is the action that a human took at that specific set of frames. But there were two outputs to the neural network. So there were two heads to the neural net. And one of them was, of course, the action to take, but the other one was a recurrent neural network that would generate a sentence as a description as to why the neural network came up with that decision based off of what humans said as to why they clicked that button. And they were able to create a neural network that would click buttons and also create textual representations of why it came to that decision. And so people have been working on these sorts of abstractions, and hopefully they continue to get more complex in the future. Again, why I'm so interested in natural language-based artificial intelligence techniques. Cool. Do you want to mention something right now? Wonderful. All right, so unfortunately, I think that's all the time we have. Any more questions from the live stream? No? All right. If you have any more questions, feel free to ask after the session. But thank you very much, Sam and Rob, for your time. Really appreciate it. And until the next time with Tech Time, thank you. Thank you. Thank you.
Nice job.
Thank you very much.
Absolutely.
Thanks.
Thank you.
Thanks.